Welcome all of you to my video channel. Mainly, tutorial videos are included in this channel. The tutorial on electrical panel and maintenance contain videos that will give more knowledge to those who want to know about electrical panels. As part of fire and smoke control, there are videos explaining fire and safety, smoke management system and smoke control system. Other videos from this video channel are easy to do home electrical work, educational videos, and descriptions of books, blogs, travel and culture. Also includes a basic description of electronics and the design and construction of a printed circuit board. Thank you for watching my videos. Subscribe to the channel to get more videos and updates. Welcome to the tutorial. Know about electrical panel and maintenance. Electrical panel. Part 5. Circuit breakers. In this part, we will learn about the circuit breakers used in the electrical panel. Knowledge of circuit protection devices is vast and important in the field of electrical panel. There are many facts and details to know in this section. In this tutorial, we have covered all the essential information that should know to a technician working in the field of electrical panel repair and maintenance. A circuit breaker is an automatic switch that is designed to protect an electrical circuit from damages caused by excess current from an overload or short circuit. Its basic function is to block the current flow after a fault is detected. Unlike a fuse normally used for this purpose, a circuit breaker is unique in that it can be set to resume normal operation once it has been activated. All circuit breaker systems have common features in their operation, but details vary substantially depending on the voltage, current rating, and type of the circuit breaker. The circuit breaker detects a fault condition in the electrical circuit. In low current circuit breakers, this is usually detecting within the device itself. Typically, the heating or magnetic effects of electric current are employed to find the fault. Circuit breakers for large currents or high voltages are usually with a protective relay device to sense the fault condition in the electric circuit. Thermal expansion or a magnetic field also used in some circuit breakers to sense high current in the electrical circuit. Small circuit breakers typically have a manual control lever to switch off the load or reset a tripped breaker, while larger units use solenoids or springs to trip the mechanism. Electric motors or hand levers used to restore energy to the springs. Circuit breakers come in a variety of sizes. From small devices that protect low-current circuits or personal household appliances to large switchgear designed to protect high-voltage circuits used throughout a city. Start the tutorial from air circuit breakers. Air circuit breaker is an electronic and electrical equipment that is used for the protection of electric circuits from short circuits or overcurrent. Air circuit breaker is using at the upstream protection of the electrical panel scheme. The electronic control system is integrated inside the ACB for the operation of all functions including earth leakage protection. ACB is using in low voltage circuits and available at the circuit current of 630A to 6300A in different frame sizes. ACB is available in fixed and withdraw type in 3-pole and 4 poles. Fixed type ACB is mounted in a frame fitted inside the MSB compartment. Withdraw type is fixed in the compartment that has movable rails and it is possible to remove from the bracket for servicing purposes. Fixed type ACB is mounted in a frame fitted inside the MSB compartment. Withdraw type is fixed in the compartment that has movable rails and it is possible to remove from the bracket for servicing purposes. ACB has a charging mechanism for the spring-loaded contact. A hand lever is using to charge the spring manually and a charging motor is using in an automatic system. Know the ACB in detail. Trip reset button. This red button will come out when the ACB trips. After correcting the error, the button must be pressed in to activate. Manual on push button. This is using to on the ACB manually. Charging handle. This handle to use the spring-loaded mechanism for closing the contacts. Manual off push button. This is used to off ACB manually. Rack in rack out lock. This push button must be pressed inwards to rack in the ACB. This button will come out when the ACB comes out of the rack. ACB rack out handle. This handle is used to pull the ACB in and out. This is available only for the withdraw type ACB. Air circuit breaker to be continued in part 6. Thank you for watching the tutorial. Subscribe to the channel to get updates and new videos. Electrical panel. Part 6. Air circuit breaker continues. User settings. This section used to set the required current, tripping current, and tripping mode. Mode and type of settings may vary depends on the model and make. Here explain the general settings provided in the ACB. IR long time current. IR is the requirement from the user. The setting shall be the multiplication of the normal current. Settings range available from 0.4 to 1. IN normal current. This is the normal current labeled in the ACB details. TR trip time in seconds. Normal tripping current will be 1.05 to 1.20 of the set long time current. The available setting for the time shall be from 0.5 to 24 seconds as per user requirement. The normal setting is at 6 times of long time current. ISD, instantaneous trip. Instantaneous tripping current shall be set at the multiplication of long time current according to requirement. Settings range available from 1.5 times to 10 times of the long time current. Other indications and parts of ACB. Manual off button. Manual on button. On-off indication. Spring charging indication. Charged means spring fully loaded and discharged indicate that spring need to charge for operation. ACB details. Here all details of the ACB provided including rated current, voltage, short circuit rating and standards. ACB rack in indication. This details given in next page. ACB locking holder. Holder for lock the operation of ACB. ACB rack in indications. This has 3 positions such as rack in, test, rack out. ACB racked in. The indicator in the top position. ACB is fully closed and ready to use. Main contact and control contacts are closed in this position. ACB in the test position. The indicator in the middle position. In this position, the main contact of the ACB will be open. Control contact is closed. Power shall be available in all control circuit for the testing of the control system. ACB rack out. Indicator in lowest position. This indicates that ACB and controls are completely open. ACB out of the rack and shall be taken out for service. ACB trip and opening coil. Control contacts. ACB closing coil. Hand charging lever. Closing mechanism. Arc chute area. Arcing chamber. Arcing contact. Arc chute. Inside view of arc chute. Arc splitters. Working principle of ACB. Air circuit breakers operate in free air with its contacts. The figure given here illustrates the principle of operation of the air circuit breaker. Here given the typical drawing of the main contact, arcing contact, and arc chute chamber. Arc chute internal view. Main contact release when a fault occurs. Arcing contact release when arc reaches. Arc runner guides the arc to splitters. Splitters are absorbing the arc fire from the contact. End of part 6. Air circuit breaker continued in part 7. Thank you for watching the tutorial. Subscribe to the channel to get updates and more videos. Electrical panel. Part 7. Air circuit breaker continues. Air circuit breakers usually have two pairs of contacts. The main pair of contacts carry the current under normal load, and these contacts are made of copper metal. The second pair is the arcing contact, which is made of carbon. When the circuit breaker is tripped, the main contacts open first, but the arcing contacts are still aligned with each other. When the arc reaches the arcing contact, it opens and allows the arc to enter the arc chute. Details of arc chute and functions illustrated with the picture given here. Know in details about arc chute and contacts. Main contact releases when a fault occurs. Arc contact releases when arc reaches. Arc runner guided the arc to splitters. Splitters are absorbing the fire from the arc contacts. arc chute box is made of insulating and fireproof material and is divided into different sections by barriers of the same material. At the bottom of each barrier, there is a small metal conductor mounted between one side and the other. The arc, which is driven upwards by electromagnetic forces, enters the bottom of the chute. It splits into several parts. But each metal conductor under the barrier ensures electrical continuity between them. The electromagnetic forces in each section of the chute give the arc of that section the shape of a helix. Since all these helixes are in the same range, the total length of the arc increases greatly and its resistance increases abundantly. This increased resistance of the circuit helps to reduce the arc voltage so that the arc becomes zero. Make the ACB normal. Reset the trip unit by pressing the red button inside. Charge the spring mechanism with hand level for normal ACB, and if it is with auto control it will charge automatically after reset. Next portion. Molded case circuit breakers MCCB. Molded case circuit breakers MCCB. A molded case circuit breaker is an electrical protection device used to protect an electrical circuit from excessive current caused by overload or a short circuit. The MCCB is currently available with a current rating of 16A to 1600A for general use and up to 2500A for special needs. MCCBs can be used for different voltages and currents as they have adjustable settings available. MCCB is a protective device that ensures safe and reliable operation in the long run. It is smaller in size than the ACB and is easier to maintain. The molded case circuit breaker can adjust the trip current according to the thermal or thermomagnetic function and also adjust the trip electronically. MCCB fulfills overload protection through a temperature control system. MCCBs have a bimetallic contact that responds to and changes with temperature. The bimetallic contact heats up according to a set current and the MCCB trips. Under normal operating conditions, the contact allows a smooth flow of electricity through the MCCB. However, once the adjusted trip value is exceeded, the contact begins to heat up and expand until the circuit is interrupted and the trip occurs. The electronic unit is using with the current transformer installed inside the MCCB to trip. According to the setting provided, the current transformer senses with the variations of the current and it leads to an instantaneous trip. End of Part 7. MCCB continued in Part 8. Thank you for watching the tutorial. Subscribe to the channel to get updates and more videos. Electrical panel. Part 8. Molded case circuit breaker continues. In this part, we will continue the protection details included in the MCCB. Different manufacturers are providing their own protection devices applied in the MCCB. In the electrical panel, MCCB is using for branch circuits. MCCB is using incoming and all outgoing sections in SMB. Explaining the general settings provided in the breaker. Thermal magnetic trip unit and electronic trip unit. Magnetic trip unit. A flow of current that exceeds the rated current with a predefined time limit. Such a fault is called overload. It is not a fault, it is a condition. Bimetallic contact involves in overload operation of the breaker. Under the normal condition, it allows the current flow. Current flow exceeds the predefined value, then it will get bent and finally, it will engage the tripping mechanism. Thermal protection for overload. This shall be the multiplication of the normal current. Example, IR setting range available from 0.8 to 1. The overcurrent protection of this 250 amp MCCB set to 0.8 means 200 amp. 250 multiplied by 0.8. Magnetic protection for short circuit. This shall be settable up to 10 times of the set current. For example, I'm setting range available 5 to 10. The magnetic protection of a 250 amp MCCB set to 8 means 2000 amp. 250 multiplied by 8. Electronic trip units. An electromagnetic coil involves short circuit and instantaneous protection of the breaker. Under normal conditions, the CT generates less current, hence the electromagnetic field is generated by the coil is not enough to pull the plunger. Therefore, the breaker does not trip. During short circuit or instantaneous fault conditions, the CT generates a high current and the coil creates a strong magnetic field. Hence the coil pulls the plunger and it will trip the circuit instantly. IO is the overload current base setting. IR used to do the fine adjustment for IR. For example, there has a setting range of 0.5 to 1 for IO and 0.8 to 1 for the IR. For a 250 amp MCCB IO setting is 0.5 and IR is set to 0.8 means the current set to 100 amp. ISD instantaneous trip, short time and instantaneous protection. Setting ranges available 2 to 10 times of long time protection. The typical setting of a short circuit will be 2 times of the overload setting and a fixed time delay of 0.2 to 0.5 seconds. End of Part 8. MCCB continued to Part 9. Thank you for watching the tutorial. Subscribe to the channel to get updates and more videos.